Today I'm going to put a video on for the review for the test. Here is the Jeopardy review game that we went over in class, and I'm going to go through the answers to the Jeopardy review game. So the first question here is a system in which energy can enter or leave but matter cannot, and that is going to be a closed system. With a closed system, energy can enter but matter is going to be stopped. There's going to be some barrier or something that's going to close that system off so it cannot freely exchange matter and both energy. So that's a closed system where only energy can transfer, matter can't. A system in which there is a free exchange of both matter and energy between the systems and the surrounding is going to be an open system. A beaker of water with no lid is heated over a laboratory burner, and that's going to be an example of an open system because it has no lid. The definition of an open system and an example of an open system is going to be a system that allows the free exchange of matter and energy, and that would be like an open bottle or an open jar. And the definition of a closed system and an example of a closed system is going to be the opposite of that. With a closed system, energy can transfer but matter cannot. And an example of that would be like a closed bottle or a closed jar, where the object inside can still get energy to pass through it, temperature can change, but the amount of material or the type of material inside cannot change. It can't move in or out. The gaseous envelope of air surrounding Earth, made up of a mixture of about 78% nitrogen, 21% oxygen, and 1% of other gases. Water vapor being one of those gases, is one of the four spheres, and that's going to be the atmosphere. All of the water in the Earth's system, water vapor, solid in terms of frozen water, liquid water, and gases, is one of the four spheres, and that's going to be the hydrosphere. The rocks, mountains, lithospheric plates, and other physical features of Earth, except for the water, is going to be the geosphere. All of the living organisms on Earth environment is going to be the biosphere. When it's a living things, it's the biosphere. Most of Earth's fresh water is locked up in ice caps and glaciers, or is frozen water. An open loop system. Okay, with an open loop system, there is no feedback. The system acts on its own. There's no way to self-correct the system. With a closed loop system, there is feedback. So with a closed loop system, there is a way to control the system, and there's a way for the system to self-correct itself, and that's by feedback. Feedback in a closed loop system is a way for the output to have an effect on the input of the system. It's a way for the system to be self-correcting and be able to make changes. If we think of the human body as a system, how does eating food relate to feeling hungry and the digestive system? The feeling hungry would be like a feedback, and as we feel hungry, then we know we need to input more food, and as we then don't feel hungry or we get satisfied or fulfilling, then we don't need to input as much, if any, food anymore. So that feedback will work as a way to kind of speed up that loop or slow down that loop. A planet is experiencing a change in its climate, making the air warmer. Because of the warmer air, there's less snowfall than in the past. This lack of snowfall allows the surface to gain more energy, causing the planet to get even warmer. The warmer temperatures cause the polar ice caps to melt, allowing the temperatures to increase. The planet's climate system is experiencing An open loop system. With this, it's going to be an open loop because there's no feedback slowing this system down. The system is working unchecked and kind of out of control, and it's going to keep expanding and keep getting worse. So that's why it's going to be an open loop system. The movement of energy into and out of Earth's system is going to be the energy cycle. The continuous circulation of water through the hydrosphere as a solid, liquid, and gas is going to be the water cycle. Energy created by the gravitational pull of the sun, earth, and move, that's going to be tides, tidal energy. The change of this element from a solid to a gas and then back again is what cycle? And this element's one of the main gases when we're talking about global warming and greenhouse emissions, and that's the carbon cycle. In this element's cycle, it changes from a gas to a solid by the work of bacteria that fix the gas to make it a solid. After the solid element is used up by plants and animals, different bacteria change that solid element back into a gas, and that's going to be the nitrogen cycle. Energy emitted by the sun is going to be solar energy. The study of Earth materials and the process subdivided into groups with 4 interconnected spheres of activity known as atmosphere, geosphere, hydrosphere, and biosphere. That's going to be the Earth science system. Physical or chemical process of Earth materials that repeats over time. For example, the water cycle, the carbon cycle, and the rock cycle. That's going to be the definition of the word cycle itself. What does the gas carbon do to the atmosphere, usually in the form of CO2? What it does is it's going to make the atmosphere warmer because carbon dioxide will absorb the re-radiated energy from the sun. It will cause the atmosphere to increase in temperature. Pollution from the chimney of a factory is an example of the biosphere interacting with the atmosphere. Pollution, anytime we're talking about pollution, that's going to be humans. Pollution is going to be a man-made thing, so we're going to talk about the biosphere, or even animals polluting with their waste. But that's going to be the biosphere interacting, and in this case, because it's a chimney, interacting with the atmosphere. In the next 20 to 25 years, no matter where you live, clean water access will become an issue due to changes in climate. All living organisms in the Earth system and their environments, one of the 4 systems, that's the biosphere. A simplified representation of an object, process, or phenomenon used as the basis for further study, that's going to be a model. Explaining how the carbon cycle works. Okay, the element carbon is going to be moved through different parts of the Earth as a solid and as a gas. Humans and animals are going to exhale and send carbon dioxide into the atmosphere. That carbon dioxide that's in the atmosphere is then going to, it causes the atmosphere to heat up. Another thing, then plants will remove that. Plants and trees breathe in carbon dioxide, and that carbon gets locked up then inside those plants and trees. With trees, it'll hold on to that carbon for a long time until those plants die and decay or are burned, and then it's released back into the atmosphere. If it's in plants, then animals will eat that and absorb the carbon inside of them, and then eventually be exhaled, and the carbon will be let back out. The other thing is with decay, a lot of times carbon will be held under the earth, and that's where we get into fossil fuels. And with fossil fuels, those things have been under the earth for hundreds of millions of years, and when burned, it's releasing that extra carbon back into the atmosphere that's been locked up for a long time. Of the 80 million single serving plastic bottles used daily, 30 million end up in landfills, and that's from the video that we watched, Tapped, on water bottles and water bottle companies. And the last question on here, give an example of how all four of Earth's spheres can interact with each other. One example of that would be pollution, where we have the biosphere, and that could be contaminating the atmosphere. It also could be contaminating the hydrosphere, and it can definitely be contaminating the soil where plants are. So that's one example. Other examples would be things like volcanic activity. Volcanic activity would be the geosphere interacting with the other spheres, releasing gas and dust into the atmosphere. It could be the lava from a volcano then interacting with a river or a lake, and that could affect the hydrosphere, and then killing trees or causing people and animals to have to move, and that would be affecting the biosphere. So there are other examples, but those are two examples of how one sphere can interact the other three spheres and have an effect on them. If you have any other questions tomorrow, feel free to stop in and ask me either before the test or during homeroom.